So in this video we are going to be looking at generators. Okay, this is the second video in this playlist. The last time we talked about iterators, and now one question one may ask is, why do you actually need iterators? Now for one, they're memory efficient. Okay, they save you a lot of memories compared to your normal loops, okay, and the rest of that, or other containers. So iterators are a good way for you to save memory when you're working on a project, because to some extent they are lazy when it comes to computation. They only give you things on request. They don't just compute things and then leave them in memory like you have in list where you have a bunch of values saved somewhere. So that's why we need iterators. Okay, and also generators. So here we want to look at how we can build generators. But before we build generator, we are going to look at how to build an iterator, of which I've done that in the last video, so I'm not going to explain a lot of things here. I'm just going to go through building this iterator. So after building this iterator, then we are also going to use a generator to still build that same iterator, and then you see the difference between them for you to know that generators are far too easier to build compared to iterators themselves. And that's what I said in the last video, and I told I was going to show you an easy method to go ahead to build something that is going to be memory efficient. So if you not watched the last video, I'll put the link in the description below. Go ahead and make use of that link, and you'll be good to go. Okay, so we want to build an iterator. Now the iterator we want to build is an iterator that is going to give us odd numbers. So it will give us odd numbers between two numbers that will be passed in. So I'm going to pass in the start point and then the end point, and then it will give me odd numbers that falls within that range. So that's what we want to do. Okay, so we said the first thing you need to do whenever I want to build an iterator, you're using classes to build an iterator. So you start with the keyword class, then the name of the iterator. So I want to call this my odds. Okay, and I just have that. Now the first method I want to build inside of it is going to be my init function, or my init method. So I have the init method. As usual, it takes at least one argument, which is self, but in this time around I want to give it the start value. I'll say the start value, I have a start value stats, and then I have a stop value. I have these two. Okay, so since I have the start and the stop value, I'll say self dot start equal to start, self dot stop is equal to stop. So the next thing I have to do is to build the current value. So for me to build the current value, I'll do a couple of things. I'll ask, okay, if self dot start percentage 2 is equal to 1. Okay, if the remainder is 1, then it means the current value is actually an odd number. So I'm going to say self dot current value is equal to an odd number, so which means I'll say it should still be the actual value. Okay, but if that's not the case, then it means the current value is not an odd number. That means if I add 1 to it, I'm going to get an odd number, right? So I'll say the current value is going to be self.start, or is going to be the start value, or let me make it self.start, then I add 1 to it. So the logic here is this: if what the user gave for start is 7, okay, 7 is going to be an odd number, this will give us 1, it will be an odd number, so the current value should also remain 7, because that's the first odd number we need. But if it is not a 7, if what the user gave is 8, then the first odd number will be after 8, which is going to be 9. So make the first odd number to be the actual value, then plus 1, add 1 to it. That's what we are doing there. Okay, so we said the iterator protocols, there are two functions or two methods that should be implemented. Please guys, if you've not gone through the last video, go ahead, go through it so that it's going to make sense. So one of the method that we need to implement is the iter method. So the iter method as usual, is a method, so it has to take in self at least rather. And then what it is going to do in this case is just to return self. So this is going to build the iterable itself. So after building the iterable, what allows you to run through this iterable is the next method. So we say dunder next, which will take in self as one of the parameters. So this is where we have to start returning values. So what do we want to return? All we want to do, whenever we call the next function, we want to return the current value. So if I go ahead, I'll say okay, return the current self.current value, right? Self.current value. So I'll say go ahead and return self.current value. Okay, so that is meant to be a return here. I don't know what's wrong with me today. So we have to return the current value. Now after returning the current value, but before we return the current value, each time we call this, we want to increase the value by 2, because if the initial value is 7, now we want to pass in 9. If it was 9, now we want to pass in 11. So we need to increase it by 2. So I'm going to say here that before you do that, self.current value should be incremented by 2. Okay, that's what I want to do. Now if I want to increment this by 2, then it means I shouldn't start. What I should do here, because if I increment this by 2, let's say what the user passed in were to be a 6 or a 7 rather, the current value is going to be a 7. When it comes here, that current value now will become a 9, and that may not be, that's not what we want. We don't want it to be 9, which is going to be the second value before it to start returning. We want it to be 7, then return 7 first, not to return 9 first, because the start value is meant to be a 7. So what I should do is this. Since my start value is 7, then what I should do here is to first of all reduce it by 2. So that is going to be a 5. That's going to now be the current value, a 5. So once it's a 5, at this point it will now increment it back to make it 7 before returning it, so that all other subsequent implementation are actually going to make sense. Okay, so I think that's it for we building this iterator. Let's just test it out and see what we have. So for us to test out this iterator, as usual, you have to assign it to an object. So let's say odds. Okay, let's just call it odds. That's the variable name I want to give to it, odds. Then I'll say my odd, which is the name of the class. So let's pass in the start value. Let's say the start value is 12, and then the stop value, let's make it 19. So I have this. If I check what odds is now, you see that it is just some class somewhere. So let's start using it and see what we are going to get. So I have to say next of odds. So next of odds will give me the first value to be 13. That's working fine. If I run it again, I have 15. Run it again, I have 17. Run it again, I have 19. Run it again, and I have 21. I'm not supposed to go beyond 21 because the stop value here is 19, but this is going beyond 19. Sorry. So what we need to do is to modify what we have here. So how do we modify it? In the last video I still discussed this. So for us to modify this is just to say if the current value is greater than the stop value. Once it's greater than the stop value, we should go ahead and raise an exception. So the exception I want to raise is the stop iter exception. Then we have to tell the user what he actually did wrong, or possibly put the blame on the user. Okay, we can just say, hey, you did something wrong, or let's put on something reasonable. Okay, you can't exceed what value we have there, self.stop, right? So we tell the user that you can't exceed self.stop, and that will work out fine. So let's run it again and try it out. So I have the first value to be 13, next I have 15, next I have 17, I have 19. Let's see if we can exceed 19. I have stop iteration right now, so it's giving me you can't exceed that. So I can actually still use a loop to run through this. So we can say for x in that, go ahead and print x. Okay, now this is not working out because I have to, I'll say for x in my odds. So let's pass in what we have. So I want to pass in between 2 and let's say 50. Let's print all odd number between 2 and 50. So this is what we have. The starting value is 3, and then we have down to 49. So that's working fine. Alright, so this is it for our iter function. But if we want to build something like this using a generator, what do we possibly do? In fact, how do you build generators? Now, generators are simply functions. Funny enough and interesting enough, they are functions. So if you remember how we can build a function, we say def, we call the function. So let's call it gen. So this function, let's say this gen is going to take just one value, let's say t, and what I want to do is just to return all values starting from t. I want to start values starting from t onwards, so I can just go ahead and say return. Okay, if it were to be a function, I would have said return t, and this is just going to return t. But what I want to do here is, instead of me using the word return, I have to use the word yield. That's what makes the generator. Once you have at least one yield in a function, that function becomes a generator. So I can return t, then go ahead and possibly return t plus 2, go ahead and return, or sorry, yield t plus 2 again, right? Or let's make it this way. I can make it t plus 4, but I don't want to do that. So what I want to do, I'm still going to return t, but if I return t this time, I'll make t to be plus equal to 2. They also take this, make t to be plus equal to 2, then go ahead and yield t. So this is what's going to happen. Unlike functions, that once a function is done executing, once it returns, that is all. Generators keep track of the endpoint. So once it encounters this one, it's going to keep track that this is where it ends. When you call the generator again, it will continue, proceeds to this part. It encounters this seed, it will return. Once you call it again, it will proceed, compute this, encounter this seed, it will return. And then when you call it again, it's going to give you a stop iteration error. Okay, so let's see what we mean by that. So I can have g equal to gen, so let's pass in 6. So if I check what g is, you can see that it's the generator. If I check for next of g, that was the first value is a 6. If I go back and run it again, the next value is 8 because it's adding 2. Call it again, next value is 10. Try it again, it's giving a stop iteration error automatically. So you can see you didn't need to start giving it a stop iteration error. Automatically it's giving you that stop iteration error because it has exceeded, it has gotten to the last yield statement there. Okay, so we are going to use this generator to build exactly what we have here, but now it's going to be with few lines of code. Here we are using about 18 lines of code or less, but now it's going to be with fewer lines of code. That's what we are going to do. So for us to build that same odd numbers using generators, we say def, this I'm going to call odds, but I'm going to call it odds modified. So as usual, like we did in the first case, to take the start value, it will take the stop value, and here we are going to use a loop. So we can say for x in range. Okay, you know what, let's not use the for loop, let's use the while loop. Okay, so first I'm going to have a current value. So let's say current value is equal to start, but I don't want to make it just start, I want to make it start plus start percentage 2. Okay, so I'm saying if the user passing 6, so the current value should be 6 plus start what's the remainder when 6 is being divided by 2, that's still going to be 0, so this will remain 6. But if these are passing 7, that's going to be 7. Is that making sense? So if these are passing 6, then it's going to be 6 okay, we want to start with odd numbers, so I'm going to add 6. Okay, I think I should subtract 1 from this, right? That should make sense. So if these are passing 6, I'm going to look for 6, then it's going to be a 5 percentage 2 will give us 1, so the start value will be a 7. But if these are passing 7, this is going to be a 6 percentage 2 is going to be 0, which is still going to remain. So I just want the start, I don't want to start using if clauses here, that's why I'm doing this. Okay, I just want to look for a way to keep track of the current value because I need odd numbers. So the current value is going to be this. Then what I'm going to do is to say, okay, while current value is less than the stop value, I want you to go ahead and start running. Okay, why is less than or equal to the stop value? Because the stop value is also possible to be returned. So I'm going to go ahead and yield. That's what I will do. So I'll yield the current value. After I yield the current value, I'll go ahead and increase the current value by 2, and that is all we have here. Okay, that's all we have to be the generator version of that we had there. So let's run it and see. So I've run this, so let's use odd equal to odd mod. So I'll pass in the start value, let's say 4, the stop value, let's use a 12, and then I run this. So if I check what odd is a generator. So if I look for next of odd, it starts with 4, which is what we expect. Run it again, that's 9, that's 11, and it can go beyond 11. So that's we building. So you can see this is exactly doing the work of this line of codes we have here. This is about 18 lines of code, and what we have here is just 5 lines of code. So that's it, guys, for this video. It's quite long, but I'm sorry about that. Just that we had to complete what I didn't want to break this video into some other sections. I wanted us to complete everything here. So I'll see you guys in the next video. Go ahead and like, subscribe, share these videos among your friends. Okay, and I'll see you guys in the next video. Bye bye.